All right, so today we're going to look at adding fractions and subtracting fractions. We're on day 4, and we're not going to do a super big notes class just because we have a long weekend coming up. All right, for you guys. Friday is no school, so I'm going to do a little bit of notes here with you guys, get the idea, sort of remind you how it works. Then we'll grab the mini boards and we'll do some practice questions. And when I see you guys next week, I guess it'll be on Monday. We'll do a couple of warm-up questions and we'll get into the assignment. All right. So just because the long weekend's coming up, I didn't want to push through the whole notes because then have you guys forget it. All right. So now, lots of teachers teach these units in different orders. I'm probably unusual. I always do multiplication before adding and subtracting, mainly because multiplication gets used, those strategies, a lot more than adding and subtracting. So I want to spend more time on that kind of stuff. But then students end up having some troubles with adding and subtracting. So I'm going to go nice and slow and sort of remind you what adding and subtracting is. When you're adding, all you are doing is counting, right? How many things you have, right? So for example, if I had a fraction that was a quarter, and I had adding a fraction which was 2/4, right? If I'm hoping your grade 7 and grade 8 teachers sort of showed you how to do these things with diagrams. So a quarter would be a shape divided into 4. So the bottom number tells you how many pieces is broken up to, like so, right? 1/4 means 1 out of these 4 are shaded, and this means 2 out of these are shaded. And if you add together, you're counting. Oh, what are you counting? You have 3 shaded pieces of size 4. That's what that means, right? 3 shaded pieces of size 4, right? And now those were the easy adding questions. If we have questions like this one, 2/3 plus a quarter, if I draw pictures of that, I go like this. The first one, 2/3, so I have to break my shape into 3s. Right, so that's like the Mercedes symbols or the peace symbol here, and I shade in 2 things. And the other one is a quarter. I have my shape like this, and I break it up into 4, and I shade in 1. Now I'm supposed to count and add these things together, but there's a problem, right? The shapes that we have are different sizes, so we can't just add these together. We can't say we have 3. 3 of what? These pieces are bigger than these pieces. So we can't add those numbers together. We have to manipulate the numbers. We have to change them. And what we have to do, and I'm hoping you remember this, is we need to find a common denominator. Right? So we look at our bottom numbers. We go, okay, we're going to resize these circles. Right? Instead of cutting into 3s, we need to figure out a number that both 3 and 4 can fit into. So they're common. They're the same, right? What number can both 3 and 4 fit into? Do you guys remember this? 12. And if you're not sure how to do this, it's all multiplication, right? So I can go grab my multiplication chart here, right? I have, oops, this is from last class. I don't need that here right now. Erase all these. Oops, come on. Race. I have 3 here. I have 4 here. And you look across and you find the multiplication that's same, right? And that's 12, right? But there's other ones that work. 24 works. 36. Technically, any of these combinations, as long as you're making the bottom the same, works. But we tried to pick the smallest one. It makes our numbers the smallest, right? So it makes it easier to work with and saves a step later on simplifying. Okay, come on over here, man. Where you're supposed to be. Come on. Move on me. All right. So we go back to our notes, and we're going to make them out of 12. And before I do that, I'm going to talk about some errors that students make. We spend so much time on multiplying and dividing, and those rules are great to get stuck in your head, but students start using those for adding and subtracting. That's where they start making mistakes. So I see students when they're adding, oops, wrong class. This is not you guys. You guys are right here. I see students, come on, load up. Come on. You're gonna do it? It's taking a while. That's weird. Should be fine. Let's go like this. Let's go back. There we go. So the main error I see is students start thinking about multiplying. They'll go like, hey, Mr. Dhaliwal, I see a 2 and a 4 here. And they start crossing things off like this. And go, oh, that's a 1 and that's a 2. You're allowed to do that for multiplying. And when dividing, you're not allowed to do that for adding and subtracting. Those are the rules for multiplying. So keep those separate, right? So we're not going to do that same. What we need to do, is make both of the bottom numbers the same. And we said it's going to be 12. So we go, okay, I need to change this to a times 4 to go to 12. And I need to go this to a times 3, right? And now we write out both of them. The first one should be in blue. The second one is going in red out of 12. But remember, if we multiply the bottom, we also need to multiply the tops. You go like this. So this one should be in a times 3 here on the top as well. 1 times 3 is 3. And 4 times 2 is 8. It's really important that you multiply both the top and bottom, because this fraction that we just made here is the same value as this. Remember, when you multiply the things to the top and bottom, or divide, you make it equivalent. That's why I spent so much time using the word equivalent. Keeps the same value. If I grab my calculator, here, I go, turn these numbers to decimals. Come on, get loaded here. I go, the first one, I go 2 divided by 3 is 0.6666. 8 divided by 12 is still the same value. We just changed how it looked. Why? So we can do some math. Now they're out of the same size pieces. We're not into this weird situation where the size of the pieces are different. We manipulated the numbers, so they're out of the same size pieces. We have 8 of them here. We have 3 of them there. Altogether, we have 11 of these size 12 pieces, or twelfths is how you pronounce it, 11 twelfths. Right? That's it. So now, with adding and subtracting, we simplify not at the beginning. You don't do any of that cross stuff. We simplify at the very end. So we look and you go, are the bottom numbers the same? If yes, we can start adding right away. If they're not, we need to make the bottoms the same. All right, so that is called finding a common denominator. But we look for the lowest, right? And it's called an LCD. Technically, if you don't use the lowest one, I'm not a big deal. It doesn't really matter to me. Right? You have to do more simplifying at the end. Right? Then we save all of our simplifying to the end. So we look at our final answer. We go 11 and 12. Can that fraction be made any smaller? No. And so that's our final answer. Okay. I'm going to change some of these questions around. Let's do this one here. We're not going to do this question here. We're going to change it. So instead of this question here, just off to the side here, let's go 5 over 9 minus 2 over 6. Okay? We want to subtract these two fractions. They're not out of the same size. So the first thing we need to do is make them out of the same size. A common denominator is needed. What is the common denominator for 9 and 6? You can do 18. Thank you, Gage. Right? So if I go here, you're not good with multiplying, just use your chart. We have 9, we have 6, we look across, they both share 18 in common. Okay, 9, so we're going to make both of them 18. But if you get stuck, remember you can always multiply by the opposite. So like you'll notice that there's a 54 here as well, right? This is quite a few that work, right? If you want the small one, it makes the numbers easier, but there's going to be others that work. So we're going to make it 18. So that means the 6 we're going to have to multiply by 3. And the 9, we're going to have to multiply by 2 to make it work. All right, so we go back to our notes. We go, okay, this one over here. Oh, that's not us. We are this one. All right. Where are we? Oh, it bounced. All right, this one to turn into 18, we multiply by 2, top and bottom. So we keep the value the same. We just change how it looks so we can do our adding. This one we times by 3, top and bottom, right? So the one on the fraction, 2 times 3 is 6. 6 times 3 is 18. We have our minus sign. And 2 times 5 is 10. So that's in blue. And 9 times 2 is 18. Okay? There you go. And that's the calculation we're going to do. Right? So what should our number on the top be? What should our number on the bottom be? Alright, so you subtract these. What do I write on the top? Yes? 16. Not 16. It's a minus sign, Gage. 4 and 18. Right? So the bottom numbers don't change, right? Because we're counting. We're counting size 18. So some of the mistakes that sometimes people make is they change the bottom number as well. It doesn't change. We're counting 10 18s and 6 18s. So you had 10 of them. You took away 6 of them. You're left with 4 18s. All right? That's it. So we've done it. You can do that. You got 75% of the marks. You look at your final answer. You go, can I make this any smaller? Is there a number that can go into 4 and 18 to make this fraction into the simplest form possible? 2. They're both even numbers. So we divide by 2. Divide by 2. Divide by 2. The answer is 2 over 9. And that would give you most of the marks. Okay? That would give you all the marks, right? Okay. All right. So let's do a couple more, at least one more. So now the questions I've done so far, that level of difficulty you should have seen in grade 8. You may not remember it because it was a while ago. Most people start teach fractions at this time of the year in the fall, so it's been a whole year since you've seen fractions. But that's the level of difficulty usually in grade 8. Now, grade 9, what's going to happen is the numbers will get bigger, so it'll be maybe a little bit harder to find the common denominator, but I give you a giant sheet to help. Also, there are going to be more negative signs. Okay? And that's what the main thing that makes grade 9 more difficult for adding and subtracting. Now, the rules are the same as before. Okay? 2 negatives can make a positive. So we're going to find pairs of negatives, positive pairs, right, of 2 negatives. Right? So now it's not as easy as it was with multiplying. Or can you pay attention, bud? Right? When we're multiplying, right, because the rules are for multiplying, dividing, 2 negatives make a positive. So we can take a negative from way over here and cancel it with a way over there. It doesn't work like that for adding and subtracting. You can only cancel negatives or pair them up if they're on the same fraction. Right? Because remember, our fraction line is just a division statement. Right? You can't cross a plus sign or a minus sign. So we can't cancel this negative out here with one of these, but we can make these 2 negatives over here disappear because these 2 negatives make a positive. Right? And we can't take this one and cancel it with that one because they're separated by a number. Right? So don't confuse the rules for multiplying. Multiplying is easier. You just take any of the negatives and combine it together. They have to be on the same fraction. All right? So now, maybe we clean it up, maybe we don't, but it doesn't really matter, right? We look at this and we go, okay, now we get to adding and subtracting. Our bottoms are different, so what number can 4 and 6 both fit into? We're going to make it out of the same size. Right? What's our common denominator for 4 and 6? Yes, Evelina? 12. Right? So you can look across your 4, look across your 6. Here's our 4, here's our 6, there's a 12 and a 12. But 24 works as well. And there's other ones that work. So we're going to go back to our notes here. I'm going to make it out of 12. So the first one, I have to go 4 times 3 to turn that into a 12, right? Top and bottom, not just the bottom, right? And the second one, I have to times by 2. 6 times 2 is 12. So the bottom number tells you what we need to multiply, right? We don't want to turn the 6 into 12, so we have to multiply that whole fraction by 2. So now, I write up the new fractions. The first one becomes 9 over 12. And I'm going to move that negative sign just to the top because it makes it less chances of you making a mistake when you're adding and subtracting, right, if it's on the top number. Then we have a minus sign here. You got 5 times 2 is 10, and 6 times 2 is 12. We're counting 12s, right? What should be the number on the top? Not 1. Right? What do we have here? We have negative 9 minus 10. Right? I can write it off to the side. What's negative 9 minus 10? You're a negative 9, you're going 19, but negative. Right? You're a negative 9, then you're going left 10 spot, which is negative 19. Right? So all that integer stuff from last year sort of comes back to adding, subtracting, kind of sometimes leads to errors. Right? And okay, we added and subtracted. Now the last half mark that you're going to earn is trying to make this thing to the smallest version of itself. Is there a number that can fit into 19 and 12 to reduce this? Is there any? No? That's it. Remember, you can use the number line up here to help. 19, look up here, it doesn't have any dots on it. That means it's a prime number. It can't get any smaller. Right? Unless you divide it by 19. Right? So you look at this, oh, that's a prime number. This one can't get any smaller. So it's already in the smallest version of itself. All right? Or you can also, like on the other question, we can go 4 and 18. You look up here. You're not sure. 4 has an orange and a red dot. And look at 18. 18 has a red dot. So they have a red dot in common. So you can divide by red. What's red? You go to the first time you see red. Red is a 2. Right? There's lots of stuff in this room. If you know how to use it, it can help make math a little bit easier. All right? Okay. So this is our final answer. Okay. And I think, let's see. I think I want to stop there. And what I'm going to do is have you got a mini board.